Hey everybody, welcome back. Today we are going to learn about the tangent ratio. The tangent ratio is a trigonometric ratio. There are three different trigonometric ratios. A trigonometric ratio is a ratio of two sides of a right triangle. Okay, so there are three of them. Tangent is one of the three basic trigonometric ratios. The three trigonometric ratios are called sine, cosine, and tangent. Today we're going to talk specifically about the tangent ratio. The tangent ratio is the ratio of the leg opposite an angle of a right triangle to the leg adjacent to the angle. Okay, now this is specifically talking about one of the acute angles. Now, if we look down here, we've got two right triangles here that happen to have a 61-degree angle. So these are similar triangles by angle. We've got 90-degree angles, 61-degree angles. So with these similar triangles, the first thing we're going to do is use them to find this value of x. So x is to 9.9776 as 12 is to 18. So we'll use our cross products. We've got 18 times x, and then 12 times 9.9776 is 119.7312. And then we divide both sides by 18. And we get x is, and we'll round to 4 decimal places, 6.6517. Okay, so there's our value of x. Now, we're going to use these numbers to find the tangent ratio for a 61-degree angle. So tangent of 61 degrees, it's the ratio of the leg opposite to the leg adjacent. So for this angle right here, the leg opposite is across the triangle. That's 18. The leg adjacent is 9.9776. Okay, so we'll do 18 divided by 9.9776, and we get 1.8040. Okay, now let's do that with the other triangle. So for the other 61-degree angle, the leg opposite is 12, and the leg adjacent is 6.6517. And it's almost exactly the same. In fact, I'm going to write it as exactly the same, 1.8040. After that, they become a little bit different, but that's only because this is a rounded number. This 6.6517 is not exact. It's a rounded number, so that threw this off a little bit. But otherwise, they came out to the same ratio, the same decimal value. In fact, if I look on this chart here, this table of trigonometric ratios, the tangent of a 61-degree angle is 1.8040. In any triangle in the world that has a 90-degree angle and a 61-degree angle, the side opposite the 61-degree angle divided by the side adjacent, the leg adjacent, will give me 1.8040 every single time. Okay, so tangent in a triangle ABC with acute angle A, so here's acute angle A, the tangent of angle A, written like this, tan A, just like I wrote tan 61 up here, is defined as the length of the leg opposite angle A over the length of the leg adjacent to angle A. So the leg opposite angle A here is the length of side BC. And for the length of the leg adjacent to angle A, that is the length of side AB. Okay, so we are going to use that information to find tangent S and tangent R. We're going to write it as a fraction and then as a decimal rounded to 4 places. So here's angle S. The tangent of angle S is the leg opposite angle S, which is 60, over the leg adjacent, which is 25. Now notice I'm not using the 65. This is not an opposite leg or an adjacent leg. This is the hypotenuse, so it's not a leg at all. We only want to use the legs for tangent. Opposite leg over adjacent leg, we leave the hypotenuse out of it. Okay, now 60 over 25 as a decimal is 2.4. Now it says round to 4 places if necessary. It's not necessary here because there's only one decimal place. So 2.4 is the decimal value. Okay, then tangent R. So here's angle R. The leg opposite that is 25. And the leg adjacent to that is 60. Notice that these are reciprocals of each other. So the tangent of each of these will be reciprocals of each other. That'll work out every time. 25 over 60 is 0.4167. Okay, so we're rounding to this 4th place, and after that is a 6. Remember, 5 or above bumps that number up. Okay, so let's do that again with B and C, and then we'll go back up here and learn something else we can do with this information. So for tangent B, so we'll write tan B equals. Okay, so here's B. The leg opposite of B is 48, and the leg adjacent to B is 14. So 48 divided by 14 is 3.4285, but after the 5 is a 7, so that bumps it up to a 6. 3.4286. Then tangent C. For C, the opposite is 14, and the adjacent leg is 48, the reciprocal of tangent B. 14 divided by 48 is 0.2916. After the 6 is another 6. That's big enough to bump that up to a 7. So it's 0.2917 or 0.2917. Okay, now 2.4, back up there at tangent S, 2.4 in this tangent column, 2.4 is somewhere right in here between these two values, which means angle S is between 67 and 68 degrees. So this angle right here is somewhere between 67 degrees and 68 degrees. I don't know for sure exactly what it is, but it's somewhere between those two. And then 0.4167 in the tangent column, 0.4167 is right in here between 22 and 23 degrees. So that means this angle right here is somewhere between 22 degrees and 23 degrees. Okay? Now this kind of makes sense because if I have a 90 right here, that means these two have to share another 90. And 67 plus 23 is 90. 68 plus 22 is 90. Whatever decimal this would actually work out to, plus whatever decimal this would actually work out to, will definitely add up to 90. And I could do that again with B, 3.4286. So under tangent, 3.4286 is right here, somewhere between 73 degrees and 74 degrees. So this angle right here is somewhere in the 73 to 74 degree range. And angle C, 0.2917, so under tangent, 0.2917 is right here, somewhere between 16 and 17 degrees. Okay, 73 plus 17 happens to be 90. 74 plus 16 is 90. So whatever decimal this would actually work out to, plus the decimal this one actually works out to, would add up to exactly 90 degrees. And in a future lesson, we'll actually be able to narrow that down to a very specific decimal value.